We also need to understand on what is the difference between balanced dataset versus imbalanced dataset. And let's talk about that. So even before I go to the animation and show you that, let me explain first. Suppose you have a data set and say you have within this data set multiple features. Features are nothing but columns. And one of the feature, which is your output variable, is going to talk about whether a customer would churn or not churn. Churn means, say you're using a specific mobile service of probably AT&T or Airtel or Cellcom, etc. If you switch to a different service provider, meaning say you switch to Verizon or maybe you switch to Geo or maybe you switch to TN, right? Whichever service provider you switch, the moment you switch from one provider to another, it is called as churn. You are churning, customer churn. If you leave a specific brand and then if you switch to another brand, it need not just be in telecom. It could be something related to e-commerce. Maybe you stopped using Amazon and probably you diverted your attention to Flipkart. So that means customer has churned from using Amazon to Flipkart. Same is the case with OTT, any OTT, right? If you're a customer who have been frequently using Netflix and if you switch to Hotstar, that's called as customer churn. And say you have various variables or inputs such as age, gender, income, educational qualification, what kind of telecom plan this customer was using, so on and so forth. And say you have data of 10,000 customers. To determine whether this data set is balanced or imbalanced, you need to just look at the output variable. If within this output variable, if you have 50% of observations as churn and another 50% of observations as not churn, then this data set would be called as balanced data set. If, say, the churn is 40% and not churn is 60%, still, you say that this is a balanced data set. 30%, 70%, still it is called as balanced. Until here, it is called as balanced, my dear friends. But if one of the classes, either churn or not churn, if one of these classes is going to have less than 30%, for example, say 29% of the observations, say customer would churn, another 71% of the customers say customer would not churn. In this kind of a scenario, you say that the data set is imbalanced or unbalanced or rare events. This kind of data would be called as balanced. Okay. Whenever you take example of any company, right, will more number of customers churn? Would more number of customers switch from one provider to another? Not really. So those are rare events. If I take example of credit card transactions, fraud and not fraud, and if, in such a data set, for instance, would majority of the credit cards be fraud? Credit card transactions be fraud or not fraud? Majority of the transactions would not be fraud. Only a few transactions would be fraud, right? So the number of fraud cases will be rare. Hence, it's called as rare event. If you take example of loan default, would majority of the customers who take the loan default? Not really. Only a small proportion of customers default on the loan. And hence, those events are called as rare events. Okay. Having discussed this part of it, if your output variable here is categorical, and if you have two classes, two categories, then you go with this rule, which says that if one of the classes, either churn or not churn, if one of the classes has less than 30% of the data, then it would be called as imbalanced dataset. If your output variable has two classes or two categories. Then this rule applies like a T. However, if you have a variable which is continuous in nature, then if you have a variable which says salaries of people who get trained on data science, obviously it depends on whether you're maintaining a running notes while listening to the session or not, because that would probably mean that you're attentive and your attendance is very important. The second variable might be whether you're watching the recorded video 2 times or not. Third variable is whether you're reading the mind map or not. Right? In that way, say there are a bunch of inputs which will determine your salaries. So your output variable happens to be salaries of people. And when we talk about salary, I'm sure you all would say that that is going to be a continuous variable. Okay. Why would that be continuous in nature? Because salaries can be in decimal format also. If you open your bank statement and if you look at the money that you have in your bank account, it might say 10,000.03, so on and so forth. So it would be represented in decimal format. So if you take salary and if you were to plot it, okay, I'm going to explain more in further detail about a specific plot called as normal distribution. For now, don't worry too much, but just remember this term. As I've told you, I have this habit of introducing the terms and terminologies, the lingo and the language in this manner, wherein I'll just keep talking about a specific term until it gets into your brain, and then I'll explain about the concepts in detail. Okay? For now, if you have a variable which is continuous in format, right, which is a continuous data type, and then when you do something called as a histogram, forget about that for now. I mean, when you look at the data distribution, if it follows a normal distribution, that means if you cut it at the center, the left side and the right side would be symmetrical. If you have this kind of a representation, then you say that your data are balanced. Okay, if your output variable is continuous, you check for the data distribution. If your data are normal, then you say that your data are balanced. Sometimes you might have data like this, or you might have data like this. All these are examples of data being non-normal. If your data are non-normal, that means your data are imbalanced. Or we say that we have rare events. Next. One more very important thing is, who determined these rules? I'm saying that if the output variable is categorical, if it has two classes or two categories, then if one of the classes has less than 30%, then you say that your data are imbalanced. Who is saying this? These are called as thumb rules. Okay, the rule that if one of the class has less than 30% of data, then it would be called as imbalanced, is called as a thumb rule. Thumb rules are determined based on the experience of people working on the projects for years together. And if majority of the data scientists, mathematicians, statisticians, economists say that if one of the class is less than 30%, we can say that it is imbalanced. There is no balance in the data. Then based on that experience, practical real world application experience, we take that as a thumb rule. Thumb rule means you need to take it with a pinch of salt, because these thumb rules are coming from the experience of the people. So a few people might say less than 20% means imbalanced. A few people might say that, you know what, if one of the classes is less than 10%, then I'm going to call that as imbalanced. Sure, you can, because it's not universally proven through any statistics. It's just a number which is coming out to us through experience of a lot of people working for centuries together. Hope that gives you some context. If one of the classes is less than 30%, only then you can consider that as imbalanced data set. Not for any other rules. Simple. Simple, right? Okay. So what if your output variable happens to be a categorical variable? And what if it has more than two classes? If you have two classes, it is called as binary. Okay, let me also write it down. If you have two classes, it's called as binary. And if you have more than two classes, or if you have more than two categories, okay, then it is called as multiple categorical data. Okay. Now, here there is no thumb rule as such, friends, especially when your output variable is categorical and if it has two classes or two categories. That is, when you have multiple categorical data, we do not have a thumb rule as such. It goes by common sense. For example, say you have a specific data set wherein you have images. Okay. You have images of tiger, lion, cat, and a dog. Just as an example, I'm taking this, okay? Just to push my idea through. If 25% of the data is tiger, 30% is lion, another 33% is cat, and say another 32%. Am I okay? So not giving you the right percentage. Maybe say another 20. I'm not usually like this, but okay. Anyways, here we have 55, and then let me say another 25. Okay, and then another 20% here. Okay, if you have a data set like this, okay, then would you call this as balanced or imbalanced? %, and 20%. I would rather say that seems like pretty okay. I mean, one of these classes is not significantly less. or one of these classes or one of these categories is not significantly large, maybe I might feel that this is balanced data set. So it goes by your IQ level, absolutely, friends. Suppose you have 10% tiger, 30% lion, another 30% cat, another 30% dog. Would this be called as balanced or imbalanced? One of the classes is significantly less in comparison to the other classes. So I would call this as imbalanced data set. Okay. But a few of you all might say, hey, probably I would also call this as balanced because 3 of the classes have equal distribution. Only one has unequal distribution. So I would still call this as balanced data set. Maybe you might want to call it in that way, sure. But then when in doubt, apply techniques assuming that your underlying data set are balanced, and also apply imbalanced data techniques, assuming that your data set is imbalanced. Try out both the techniques. Whichever techniques give you good results, stick to that. When in doubt, experiment. When in doubt on which profession should I choose, should I pursue engineering or should I pursue medicine? Or should I try out becoming a sports person? Then try out all three, right? First, do your engineering, pursue that. If you are able to do well, proceed further. Or if not, come do your medicine for another 4-5 years. Pursue, and if a lot of patients are dying, then probably you're good at sports, so play sports. Yeah. Jokes aside, but then whenever you're in doubt, especially when it comes to data science, you are expected to experiment, friends. Okay, experiment. Apply techniques assuming data are balanced, apply techniques assuming data are imbalanced, and see which of these techniques is giving you good results. Stick to that.